Hello. Hello my dear students, very good evening to all. So first of all I welcome to GTQ questions for GATE 2026 for electrical electronics, power electronics. Okay. So here we are going to discuss about 10 questions in power electronics. First go through the question in detail. Okay. So you can maximum take 2 minutes at the most. So for GATE examination, accuracy is very important. Speed and accuracy is very important for GATE examination. I hope you might have revised all the basic concepts of power electronics, what we have already discussed in the regular course, right? Now let us start with the first question, dear students. If you go through the previous papers, during the COVID time, just before COVID, questions asked in power electronics were little bit tough questions, but after COVID, questions of power electronics little bit easy. Okay. So accordingly we have prepared the questions. Please go through the questions, take 2 to 3 minutes, and accuracy is very important. Yes, go through this question my dear students. Question number 1, we are having some supply voltage and power converter is there. The equation for supply voltage is 4 plus 8 sin 100 pi t plus 10 plus 5 into sin of 100 pi t plus 50. Okay. So what is the RMS value of supply voltage? Dear students, tell me what is the RMS value. Please calculate fast. What is the RMS value of the supply voltage? What is the RMS value of supply voltage? Make it fast, students. What is the RMS value of supply voltage? Yes, students. Fast. What is the RMS value of the supply voltage? So what is the right answer? Yes. Yeah, got it? Most of the students are doing similar mistake, I hope. 2 persons gave the right answer and 3 to 4 persons are giving same mistake. Same mistake is done by most of them. Here 90% of the students repeat the same mistake. Be careful, read the equation properly. Dear students, go through the equation properly. I will give the hint. See the frequency, this is the DC. See, this is the DC quantity. Here frequency is 100 pi, here also frequency is 100 pi. That means these two frequencies are same. Dear students, these two frequencies are same. Frequencies are not different, but only phase angle is different. See here, phase angle is different. Let us suppose that this voltage is V1 volts and this voltage is V2 volts. Okay. So I can write V1 is equal to 8 at an angle 10 degree, which is leading, because same frequency, right? When frequencies are same, you can use direct summation, and V2 is equal to 5 at an angle 50 degrees. Okay. So frequencies are same for V1 and V2. See here, they are not harmonic components. Frequencies are same for both the components. That is the important point you have to understand here. Okay. Now what is the vector sum of this resultant voltage? Can you find out the vector sum of this resultant voltage? What is V1 plus V2 here? V1 plus V2 is equal to 8 at an angle 10 degree plus 5 at an angle 50 degree. Okay, you can convert this into rectangular format, add them, again convert into polar format. If you add this, you will get 12.3 at an angle 12.3, okay, at an angle 25.2 you will get. This is V1 plus V2 vector sum. Okay. Now what is the resultant RMS voltage? First DC quantity we are having here. So when you have DC quantity is 4, no? Here the DC quantity is 4 under root of 4 square. Now this is the peak value, right? See, this is the peak value. Its RMS value is 12.3 by root 2, its RMS value whole square. So just simplify this. You will get 9.57 volts. You will get 9.57 volts. So option D is the right answer. Dear students, here option D is the right answer. Okay, please go through this. Answer is option D. The general mistake, most of the students will do mistake. Actually frequencies are same here. So that is the important point you have to write. But normally when harmonics are there, frequencies are different. When frequencies are different, most of the students will do like this. Vrms is equal to under root of 4 plus 8 by root 2 whole square plus 5 by root 2 whole square. If you calculate this, you will get 7.78. You will get 7.78. This is wrong answer. This is wrong. This is the mistake people will do. Why it is wrong? Because frequencies are same here. When frequencies are same, you can add them directly, the vector sum. You need not use this method. You can use this method only when frequencies are above fundamental, third harmonic 300 pi t, then you can use this method. When frequencies are same, you have to use this method. See, 90% of the students done the same mistake. That is the reason I have given this question. Okay, so you have to understand and you have to observe the question properly. Observation is important. People, you did not observe the frequencies of these voltages. Just directly you came to this point, I hope, most of the students, without observing the frequencies. So when frequencies are different, suppose fundamental frequency is 100 pi, third harmonic frequency 300 pi, then this is right. But when frequencies are same, we have to follow this method. So that is the important observation you have to understand in the question. Okay. I hope it is wonderful. I hope you understood the mistake, students. Clear? So be careful, dear students. Go through the question properly. Okay, the moment you see the question, you are becoming fast and you are excited. When you are excited, you don't have observation, then that result in negative marks. That means you don't have perfection. You don't have proper observation in the question. That result in negative marks. Okay? Be careful, dear students. Observation is very important in the question. Okay? Read the question properly, each and every point. Don't miss any point in the question. In spite of having very good concept, because you did not read the question properly, many persons done the same mistake. Okay? Fine. Shall we go for next question, students? Okay? Dear students, shall we go for the next question? Yeah. Yes, go through this question, students. All of you go through this question. Which of the following statements are true for a power BJT? Okay? Which of the following statements are true for a power BJT? Statement A. The thickness of the drift region determines the breakdown voltage, and that can range from tens to hundreds of micrometers. Once again I repeat it. The thickness of the drift region determines the breakdown voltage and can range from tens to hundreds of micrometers. Yes, this is the right answer. The base thickness is made, this is true statement, I don't say right, I will say it is a true statement. So this statement is true. Next, second statement, you see, the base thickness is made as small as possible. Okay? The base thickness is made as small as possible in order to have good amplification capabilities. Yes, this is also true statement. The base thickness is made as small as possible. That means if the base thickness is lesser in BJT, we can improve the amplification capabilities. Okay? Then that is true statement. Statement C. Practical power transistors have their emitters and base interleaved as narrow fingers, and this is required to prevent current crowding and consequent secondary breakdown. Okay? So this is also true statement. That means all statements are true. So option D is the right answer. Okay? Yes, option D is the right answer. Okay? Right, students? I hope it is clear to you. So shall we go for next question? Yes, please go through the question number 3. All of you solve the question number 3. Again, AC voltage is given. The equation for AC voltage I will give here. Equation for AC voltage is Vm into sine of omega t. Okay? A power converter is given. The output voltage of the converter is given here. You can see here. It is a rectifier, right? So this is a kind of rectifier. Okay. So for this, find out the average value of output voltage. Find out the average value of output voltage. Yes, fast. Dear students, This is some type of rectifier, okay, some type of rectifier, this one mainly used for power factor improvement methods, okay. We call it as symmetrical angle control. Yes, try to find out the average value of output voltage. Yes, fast. Yes. Yes, what is your answer? Yes, students, what is your answer? Yeah, it is very easy question. Yes, you can do it. Just look here. Here time period is pi radians, okay. Time period of this is a 2 pulse converter. Time period is pi, okay. 1 by time period into area of the waveform, average value. So time period is pi. What is the area? Integration of, see here, this angle is pi by 2, okay. Center angle is pi by 2, okay. Now what is this length from here to here? Wait, can you tell me what is this length? What is this length? What is this angle? This angle is, you know, this is pi by 2 minus beta by 2, this angle. So this angle is pi by 2 minus beta by 2, and this angle is pi by 2 plus beta by 2. Dear students, I will show it, I will enlarge here, okay. It is like this. This is pi by 2, okay. This angle is pi by 2 minus beta by 2. This angle is pi by 2 plus beta by 2, okay. So that this total length is beta, okay. So we have to use these two limits while integrating and finding the area of the waveform, okay. So 1 by time period, lower limit is pi by 2 minus beta by 2 up to pi by 2 plus beta by 2, and this equation is given by peak voltage Vm sin of omega t d omega t. Yes, simplify this one all of you? Just simplify this one and tell me what is the answer. Yes, students, try to simplify and tell the answer to this. Yeah, you have to understand these limits. You have to understand these limits. See here, this is beta by 2, okay? This is beta by 2. So from here, what is this length? This length, this is the lower limit. See, this is pi by 2, this length is pi by 2 minus beta by 2, this angle. This angle, how you get? Pi by 2 plus beta by 2, okay? So first try to understand the limits so that you can integrate and find out the area of the waveform. Okay, I hope you understood. Yes, please try to integrate this and find out the area. So finally, what is the answer? Yes, fast. What is the answer, students? Yes, students, what is the answer? Yes, right answer. Yes, most of the students has given right answer, okay. So answer is option C. Option C is the right answer, okay. Just simplify this, you will get 2 Vm by pi sine beta by 2, okay. So option C is the right answer, students. So for this question, option C is the right answer, okay. Yeah. Dear students, I hope you guys have go through the quick revision program in power electronics. Definitely, I hope it will be useful for you. Okay. Yeah. Go through the next question, students. Yes. Question number 4. Dear students, please go through the question number 4. The output voltage of unipolar PWM inverter is shown in the figure. Okay. Find the values of alpha 1 and alpha 2 to eliminate third and fifth harmonics in the output voltage. Find the values of alpha 1 and alpha 2 for eliminating the third and fifth harmonic components in the output voltage. Yes, fast. Fast. Fast, students. Right. I hope it is completed. Yes. Dear students, make it fast. What is the answer for this question? Yes, students, please try to calculate this. just use the Fourier series for this waveform and find out the nth harmonic voltage and just substitute, then verify which option is because it takes more time to use numerical methods to calculate alpha 1 and alpha 2. Just substitute, verify which one is right answer. Okay. Yeah, what is the answer? Dear students, I hope you might have completed. Tell me what is the answer now. Yes, make it fast. last 1 minute I will give hint to you. The waveform is having half wave and quarter wave symmetry. First find out the equation for nth harmonic output voltage in terms of alpha 1 and alpha 2 you will get. Then next find out the third harmonic and fifth harmonic and equate it to 0. You will get two equations and two unknowns. So basically you have to solve the equations and find alpha 1 and alpha 2, but to solve the equations we have to use numerical methods. So substitute this option A, option B, option C, option D. Which options are matching, that is the answer. Okay? Yeah. Verify this. Yes students, let me solve this question. Yeah, see we have to find out the Fourier series for this. So for this waveform, the equation for nth harmonic voltage is Bn into sine of n omega t, because An is 0. Why An is 0? This waveform is having half wave and quarter wave symmetry. Okay, so because of half wave and quarter wave symmetry the value of An is 0. So only Bn we have to consider, right? So here Bn value, how to calculate the value of Bn? To calculate the value of Bn, quarter cycle 2 by out of quarter cycle, integral 0 to quarter cycle now. So first integral 0 to alpha 1, what is f of omega t? It is Vs into sine of n omega t into d of omega t. Okay, plus integral alpha 1 to alpha 2, this voltage is 0. Integral alpha 1 to alpha 2 plus integral alpha 1 to alpha 2, the voltage is 0. Sine of n omega t into d omega t plus from alpha 2 to up to pi by 2. Once again the magnitude is Vs only, okay. Once again the magnitude is Vs only, sine of n omega t d omega t. So, just simplify this, and finally what is the nth harmonic amplitude? Formula 4Vs by pi into 1 minus cos of n alpha 1 cos of n alpha 1 okay, 1 minus cos of n alpha 1 plus cos of n alpha 2 whole divided by n. So, this is the nth harmonic amplitude. Now, I want to find out the third harmonic amplitude. So, what is the third harmonic amplitude? B3. Substitute n is equal to 3. 4Vs by pi into 1 minus cos 3 alpha 1 plus cos 3 alpha 2 by 3. So, here I want to eliminate the third. So, equate the third harmonic voltage to 0 because I want to eliminate the third. So, from this I can write 1 minus cos 3 alpha 1 plus cos 3 alpha 2 is equal to 0. This is equation number 1. Then equate the fifth harmonic voltage to 0. What is fifth harmonic voltage? 4Vs by pi into 1 minus, substitute n is equal to 5 here, 1 minus cos of 5 alpha 1 plus cos of 5 alpha 2 by 5. Equate this to 0 because I want to eliminate the fifth harmonic also. So, therefore, 1 minus cos of 5 alpha 1 plus cos of 5 alpha 2 is equal to 0, equation number 2. So, we have to solve the equations 1 and 2, we have to solve equations 1 and 2 to find alpha 1 and alpha 2. Actually, here we have to use numerical methods and solve the two equations, okay, but it is objective questions, okay. So, you cannot use numerical methods, it takes more time. So, simple logic is you have two equations here. Now, use this options here, substitute here. What is the first equation here? First equation 1 minus cos of 3 times alpha 1 plus cos of 3 times alpha 2 0. This is the first equation. Second equation 1 minus cos, okay, 1 minus cos 5 alpha 1 plus cos 5 alpha 2 is equal to 0. This is the equation number 2, okay. Now, we have to solve these two equations, and find the values of alpha 1 and alpha 2. So, one is numerical methods we use, another one is first you substitute these values. If you substitute these values, if it is equated to 0, then that is the right answer. But if you substitute this one, I will tell you what is the right answer. This is wrong, it will not match with this, even this will not match with this, okay. This is right, this is also wrong. Just substitute these values here, it will match. So, that is why answer is option C. Please verify, students, option C is the answer here, okay. Here option C is the right answer, okay. So, I hope everything is clear to you, students. Option C is the right answer here, okay. So, try to solve this one, okay. You can also use, if it is asked in the mains examination of IAS, There we have to use numerical methods, solve the equations and calculate the values of alpha 1 and alpha 2. Okay? So, I hope everything is clear, my dear students. So, answer to this question is option C. I hope you might have verified this. Okay? Fine. Yeah, let us go back to the next question. Please take down this. Okay? Okay, students. Yeah, let's go back to the next question. Okay. Yeah, try to solve this question. Question number 5. So, what is this converter? We are having inductor here. So, low voltage side, high voltage side. When you on the switch, inductor is storing energy in the first mode, and when you disconnect the switch, it is discharging energy. This is the second mode. Here power flows from low voltage to high voltage side. So, this is actually the boost converter. Boost converter. Okay. So, they have this is the resistance of inductance. This is not ideal one. Okay. So, they have given the resistance of this inductance 0.1 ohms, load resistance is 10 ohms, okay. Inductance is 50 millihenry, supply voltage is 100 volts. Let us assume continuous conduction here. That means the shape of IL waveform is continuous conduction. This is continuous. Find out the peak blocking voltage of the switch. Okay. So, here in the case of a boost converter, the blocking voltage of the switch is output voltage. That means we indirectly we have to find out the output voltage here. So, indirectly what we have to calculate, students, just find out the output voltage, because in the case of boost converter, the output voltage of the converter is the blocking voltage of the switch. I think we have done in the regular course also. In buck converter, switch and diode must be capable to block maximum supply voltage. Okay. In boost converter, switch as well as diode must be capable to block maximum output voltage. Okay, so that means blocking voltage of the switch is output voltage here. So we have to find out the equation of output voltage considering the resistance of inductance practically. You see here, normally what is the mistake people will do here? Normally people will use this formula V0 is equal to Vs by 1 minus alpha, which is wrong. You can use this formula only for ideal case where small r is 0. This is for ideal case, okay. But in this question they have given the resistance of that inductance, okay. Now if resistance of inductance is given, then in that case we have to find out the blocking voltage of switch. So what is the equation here for practical case? Equation for practical case is V0 is equal to Vs into 1 minus alpha by small r by capital R plus 1 minus alpha whole square. Okay students, so this is ideal case, this is practical case. Practical case considering the resistance of this inductance. Now we have to find out the peak blocking voltage, means what is the maximum voltage, what is the condition for maxima here? We have to find out maximum voltage here, we have to find out the maximum voltage. So what is the condition for maxima here? I have a function f of alpha here. Condition for maxima, condition for maximum output voltage or maxima. Condition for maxima is f dash of alpha is equal to 0. That is differentiate the above equation with respect to alpha. So Vs into 1 minus alpha divided by small r by capital R plus 1 minus alpha whole square. Okay, so that is equate to 0. Equated to 0. So if you simplify this, you will get the one value of alpha, condition for maxima. Okay, if you simplify this, you will get alpha maximum is equal to, if you simplify this, you will get alpha maximum is equal to 1 minus under root of small r by capital R. Yeah, that is the condition for maxima. Now substitute this value here, you will get maximum average voltage. Okay, so the peak blocking voltage of switch is maximum voltage. So how do you calculate maximum voltage? Substitute this value of alpha in this equation and find out the maximum voltage. Find out the maximum voltage. So Vs into 1 minus maximum alpha is, what is the maximum alpha? 1 minus alpha. See, I will do one thing here. If you take this side square 1 minus alpha maxima is equal to square root of small r by capital R. Okay. So directly you can write this, substitute in that Vs into 1 minus alpha, you can write it is square root of small r by capital R by r by capital R plus 1 minus alpha whole square, that is r by capital R whole square. Whole square means the same thing I think you will get here, because you are doing whole square na. Okay. So how much you will get this one? This is 2 Vs, 2 into, right? So denominator will get 2. Maximum voltage is Vs by 2. Vs by 2. Denominator we have under root of r by capital R. Okay, Vs is 100 volts by 2 into under root of small r is 0.1 by 10. 0.1 by 10. 0.1 by 10. So, this is the maximum voltage, that is the peak voltage. Simplify this, students. Tell me what do you get after simplifying this. Okay, I think you will get 500 volts here, I hope, right? Yes, you will get 500 volts, that is the answer. So, that is the peak blocking voltage of switch, that is the peak blocking voltage of switch. This is the point students should understand here. Okay, main point is the peak blocking voltage of switch is maximum voltage of output. So, first write down the equation for output voltage, practical case. Condition for maxima, if you simplify, you will get alpha maxima. Substitute this alpha maxima here, so that you can calculate maximum value of output voltage. Okay, students, I hope the concept is so clear to you. Answer is 500 volts. Yes, right answer. 500 volts is the right answer. Okay, done. Make it fast. Okay, done all of you? Okay, next question students. Try the next question, all of you. Question number 6. A DC to DC converter is shown in the figure, okay. The duty ratio of the switch is 0.4, okay. So here alpha duty ratio of the switch 0.4 operates at a frequency of 20 kilohertz. Small correction dear students, frequency take it as take it as 10 kilo, okay, 10 kilohertz, small correction, take this frequency 10 kilo, this is 10 kilohertz, okay, assume all components to be ideal. See what is the peak current in the switch. So here current passing through the switch, so we have to find out the peak current in the switch. Yes, this is nothing but buck boost converter. I hope you understand. Buck boost converter. This is the buck boost converter. Find the peak value of current in the switch. So if you observe here, supply voltage, output voltage are same. When supply voltage and output voltage are same, at alpha is equal to 0.5. At alpha is equal to 0.5, when the switch is on, inductor will charge and current is rising linearly. When alpha is equal to 0.5, see here, when alpha is equal to 0.5, okay. So in the first mode, when you turn on the switch, okay, when you turn on the switch, inductor voltage is Vs. So inductive current is linearly rising at a slope of 100 by L, because Vs is 100, it is linearly rising. So here this is for 50% of the duty cycle, 50%. This is the T on where switch is in the on state. Okay. So this is the first mode. Okay. In the first mode, until the switch is on, inductor is charging and current is linearly rising at a slope of 100 by L. And in the second mode, the moment you disconnect the switch, inductor is discharging energy like this. So in the second mode, voltage of inductor is reversed, that is equal to V naught is 100 again. That means at what slope current is linearly rising, at same slope it is linearly dropping for another same time, another 50% of the duty cycle where diode is on. So if you observe here, inductive current is at the boundary. So current is linearly decreasing at a slope of minus 100 by L. So at alpha is equal to 0.5, inductive current is at the boundary. Inductive current is at the boundary. Okay. So here alpha is less than 0.5. Okay. If alpha is less than 0.5, we get discontinuous conduction. So here, if alpha is lesser than 0.5, then the shape of IL is discontinuous. So concept is clear. So here student should understand that the shape of IL is discontinuous conduction. Okay. So if it is discontinuous conduction, let me draw the waveform for IL when duty ratio is 0.4. When the duty ratio is 0.4, okay, it is linearly rising at a slope of 100 by L. Okay. At a slope of 100 by L, linearly rising up to 40% of the duty cycle. Then at same slope it is linearly discharging for another 40%. This is the beta T. Okay. So here switch is on, here diode is on. Then for remaining cycle discontinuous. So here I want to calculate the peak value of switch current. See, this is the peak value of switch current. The peak value of switch current is same as the ripple in the inductive current. See here, that is nothing but switch current, right? So peak value of switch current is same as ripple. So you can note down that point here. Okay, the peak value of switch current. The peak value of switch current same as I maxima, that is delta IL, because it is discontinuous. What is delta IL for buck boost converter? It is alpha into Vs by F into L. So alpha is 0.4 duty ratio, supply voltage is 100 volts, by frequency is 10 kilo, 10 into 10 to the power 3 into the value of inductance is 20 milli, 20 into 10 to the power minus 3. Okay. So here if you observe here, this will cancel with this, and okay. So 0.4 by 2, please verify this, dear students, please verify this. This is 10 kilo, dear students. Here frequency is inductor value is, what is the value of inductance, students? What is the value of inductance? Yes, 20, no? Yes. So how much you are getting answer? 0.2 Henry. Yes. So answer to this is 0.2 Henry. 0.2 amperes, small correction, 0.2 amperes. So that is the peak value of switch current. The peak value of switch current is 0.2 amperes. Okay, the peak value of switch current is 0.2 amperes. Okay, fine. Okay, students, I hope it is clear to you, right? Yes. Next question, students. I hope it is completed. Next. Yeah, go through the question number 7. Dear students, in a bipolar PWM inverter, output voltage across the load is given. What is the fundamental amplitude of output voltage when third harmonic voltage is eliminated? Yes, all of you try this question. This angle is alpha. Okay, this is pi minus alpha. Okay, this is pi. Fine. Yeah, please make it fast. Yeah, done all of you? Dear students, is it completed? Yes, so here what is the nth harmonic amplitude here? This is also having quarter wave symmetry. Nth harmonic amplitude is given by, see here, nth harmonic amplitude, that is Bn value 4 into Vs by pi, 4 into Vs by pi into 1 minus 2 cos n alpha by n. Please verify this. 4 into Vs by pi, 1 minus 2 cos n alpha by n. Now I want to eliminate third harmonic amplitude. So third harmonic means n is equal to 3. 4 Vs by pi, 1 minus 2 cos 3 alpha by 3. 1 minus 2 cos 3 alpha by 3 is equal to 0. Okay. So let us eliminate this third. So we have to eliminate this third. So how to eliminate this third? Equate it to 0. So 1 minus 2 cos 3 alpha is equal to 0. Okay. So cos of 3 alpha is equal to 1 by 2. That means 3 alpha is equal to 60 degrees. Alpha is equal to 20 degrees. Okay. Okay. So here alpha is 20 degrees. So fundamental amplitude we have to calculate. So fundamental amplitude means we have to calculate the value of B1. Okay. So calculate the fundamental amplitude. B1 is equal to 4 into Vs by pi 1 minus 2 cos alpha by 1. Alpha is 20 degrees. So B1 is 4 Vs by pi into 1 minus 2 cos 20 degrees. Okay. So calculate this value, students. Yeah, please verify calculation part. Yes, what is the answer, students? Please try to calculate this value. So what is the answer? Minus 1.1 minus 1.119 minus 1.119 volts. Yes, minus 1.119 volts. Okay, that is the answer. See, normally in gate examination, power electronics weightage, mostly it varies from 8 marks to 12 marks. Okay, sometimes 8 marks, sometimes 10 marks they have asked, sometimes 12 marks also, in that range. Yeah. So I hope everything is clear, students. Okay. Yes. So, shall we go back to next question? Yes, question number 8. Dear students, please go through the question number 8. Okay. Now see here, find the average supply current on DC side. So here 3-phase VSI 120 degree mode, 3-phase VSI 120 degree mode. Okay. In this case, okay, what is the shape of R phase voltage waveform? What is the shape of R phase voltage waveform? R phase voltage and R pole voltage are same here. So, first 2 pi by 3 radians, its magnitude is Vs by 2 volts. It is a quasi square wave. Okay. Four pi by 3, 5 pi by 3, and then 2 pi. This is the omega t. So, here we are getting quasi square wave. We have to find out the average supply current. First of all, what is the phase voltage RMS? Phase voltage RMS, if we calculate, magnitude is Vs by 2 volts. Out of pi radians, the pulse width of the quasi square wave is 2 pi by 3 whole power 1 by 2. Okay. That is the RMS value of phase voltage. So, that means it is Vs by 2 into square root of 2 by 3. So, phase voltage RMS is equal to root 2 gets cancelled, Vs by root 6. Okay. Vs by root 6. Dear students, please correct this. Here Vs is 100 volts supply voltage. So, 100 by root 6. 100 by root 6. Now, we want phase current. Phase voltage by load resistance. Okay. So, 100 by root 6 by R is 10. So, 10 by root 6 amperes. Now, what is the output power? Output power. Power loss in 3 phases 3 times phase current whole square into R. So, 3 times phase current whole square is 10 by root 6. Okay. 10 by root 6. 10 by root 6 whole square, 10 by root 6 whole square into R is 10. Okay. So, just try to calculate these values. how much you will get. Then what is the input power on DC side? Input power on DC side is Vs into Is. So power balance equation, you can use the power balance equation straight away now. So from the power balance equation, input power on DC side is Vs into Is, that is 3 times phase current whole square 10 by root 6 whole square into 10. Here Vs is 100. So 100 into Is is equal to 3 times 10 by root 6 whole square into 10. So find the value of supply current, unknown value supply current on DC side. So calculate this. Dear students, please verify this one. Okay, just verify this one. Okay. So just equate the input power and output power, power balance equation, and finally what is the answer? So 5 amperes you will get. So that is the answer, right? So supply current on DC side is 5 amperes, right answer. Right answer students, answer is 5 amperes supply current on DC side. Okay. Yeah, just use the power balance equation. Equate input power on AC side is equal to output power on AC side is equal to input power on DC side. You will get the supply current. Okay. So I hope everything is clear, students. Yes, done all of you? So here, dear students, in 3-phase VSI, already in the regular course I said to you, here mainly students should remember the line voltage VRY, which is common for star and delta, and R phase only for star. You remember these waveforms for both 180 degree mode VSI and 120 degree mode VSI. If you remember these two waveforms, definitely you can answer most of the questions in 3-phase VSI. Okay. So I hope it is clear to you. Yeah. So we will go for the next question, students. Next question. Yes, question number 9. Go through the question number 9, all of you. Question number 9. Yes, make it fast, students. Yes, students, just convey the message to me. What is this converter? What is this converter? This is an isolated buck boost converter, flyback converter, SMPS, switch mode power supplies. I think you might have remembered. It is isolated buck boost converter, that is nothing but a flyback converter, okay? Flyback converter, isolated buck boost converter. We are using 2 winding inductor or transformer, okay? So, we have to find out the peak blocking voltage of switch and also PIV of diode, okay? Yes, done all of you? Yes, fast students. Yes, done all of you? Yes, students. So here, what is this converter called here? Flyback converter. That is also known as isolated buck boost converter. Okay. That is also called isolated buck boost. See here, A is equal to N2 by N1. So A value is 5. A value is 5. Fine. How do you find output voltage here? V0 is equal to A times of alpha Vs by 1 minus alpha. Okay, we have to calculate V0 here. A value is 5, so 5 times alpha is 0.9. 0.9 into supply voltage. What is the given supply voltage here? Supply voltage is given here, not given. Let it be 100 volts here. Okay. See here, supply voltage is not given in the question. Consider the supply voltage is 100 volts. Okay, supply voltage is considered as 100 volts. So 5 into 0.9 into 100 by 1 minus 0.9. Yes, first we have to calculate the output. Yes, please try to calculate the output. Dear students, 0.9 into 100. I think you will get 4500. Please verify this. Yes, 4500 volts. Now, first of all, when you on the switch, inductor is charging here. So when the switch is in the on state, this diode remains off. So this is V1 volts and this is V2 volts. Okay. So when the switch is on, just look here. When the switch is on, diode is off in the first mode. In this mode, V2 is equal to N2 by N1 into V1, that is A times Vs. A times Vs. That is V2. Now what is the voltage across the switch? Minus plus, minus plus. So here voltage across the switch is V2 plus V0. That is the PIV. So therefore PIV rating of diode is V2 plus V0. V2 in the first mode is A times Vs plus V0. A value is 0.9 into 100. A times Vs. A times Vs plus V0 is 4500 volts. So this is 0.9 into this. So 90 plus 4500 volts. So calculate this value. So 4590, am I right? Please verify, students. 4590. So this is the PIV rating of diode, 4590 volts. So that is the PIV rating of diode. Okay, students, got the answer? And find out the blocking voltage of switch. I think you know this formula here, second mode. I will show you the second mode now. I will show you the second mode so that you will have very good clarity here. Yes. Now, when the switch is in the off state, yes, when the switch is in the off state, automatically diode will on. Okay, second mode. When diode will on, V2 is equal to V0, second mode. V2 is equal to minus V0. So V1 is equal to N1 by N2 into V2. So V1 is equal to minus V0 by A. Okay. Now what is the blocking voltage of switch here? The blocking voltage of switch, the peak, forward, blocking voltage of switch. Okay, the peak forward blocking voltage of switch. What is the peak forward blocking voltage? That is nothing but this voltage will reverse in the second mode, plus minus, plus minus. So Vs plus V0 by A, that is the formula. Vs is 100 volts. V0 is 4500 by 0.9, because the value of A is small correction, the value of A is 5. Okay, so 100 plus 900, so 1000 volts. So that is the blocking voltage of switch, students. The peak blocking voltage of switch is 1000 volts. So that is the right answer. Okay. So just go through this question, students. So PIV of the diode is 4590 volts and the peak blocking voltage of the switch is 1000 volts. Okay. So any clarifications from your side? So I hope everything is clear, right? So yeah, over. The last question, dear students, last question. This is the last question here. Normally in gate examination they will ask 7 questions or 6 questions, sometimes 8. Till now they did not ask 10 questions, but I am explaining 10 questions today. Okay. Now what is the output voltage of the inverter is given here. Actually you will get in multi-level inverter. What is the fundamental amplitude of output voltage here? Yes, very good question. Dear students, try this question, all of you. Please try this question. I will give 5 minutes time to you. I will give 5 minutes time. Please try this question. Okay, what is the answer? Dear students, make it fast. See, I can rewrite this waveform in this way. See, I can rewrite this waveform like this, okay. VA, then VB, alpha 1 to pi minus alpha 1, alpha 1 pi minus alpha 1, okay, alpha 1 to pi minus alpha 1, this is pi, and then pi plus alpha 1, this is pi plus alpha 1, and then this is pi plus alpha 1, 2 pi minus alpha 1, 2 pi minus alpha 1, and then 2 pi. Just see here, from here to here it is Vs, this is Vs quasi square wave, this is also minus Vs quasi square wave, okay. This is alpha 1 pi minus alpha 1. So, tell me what is the pulse width of this quasi square wave? What is the pulse width of this quasi square wave? So, for this quasi square wave, the pulse width is equal to, see, this is pi minus alpha 1 minus alpha 1. Dear student, this is pi minus alpha 1. Okay, before going to that, and here between these two limits you see here, between alpha 2 and pi minus alpha 2, alpha 2 and pi minus alpha 2, alpha 2 and pi minus alpha 2, pulse width is 2d. Similarly, here also between these two, again Vs, again here minus Vs. Now, you add these two here, you will get this. If you add, that means the vector sum of these two, you will get the output voltage, simple logic. So, first of all, in the first case the pulse width is, this is pi minus alpha 1 minus alpha 1, pi minus alpha 1 minus alpha 1. So, D is equal to pi by 2 minus alpha 1. So, for quasi square wave, nth harmonic amplitude is 4 into x by n pi sin of n into d. Now, what is VAN? What is the nth harmonic amplitude here? What is the nth harmonic amplitude here? So, nth harmonic amplitude 4 into Vs by n pi into sin of n into d value is pi by 2 minus alpha 1. Okay, so you will get VAN is 4 into Vs by n pi cos of n alpha by 2, okay, cos of n into alpha 1 by 2. Similarly, for this quasi square wave, the pulse width is pi minus alpha 2 minus alpha 2. So, again D is equal to pi by 2 minus alpha 2. So, again what is VBN here? VBN, nth harmonic amplitude is 4 into Vs by n pi sin nd, sin of n into d value is pi by 2 minus alpha 2. So, VBN amplitude is 4Vs by n pi cos of n alpha by 2. Okay. Yeah, by 2 you will not get, small correction. See here n alpha 1, you will not get this by 2. Okay students. Now what is the resultant amplitude? See here, nth harmonic resultant amplitude is nth harmonic VAN plus nth harmonic VBN. So nth harmonic amplitude of the resultant is 4Vs by n pi is common. Add these two, this is alpha 2, cos n alpha 1 cos n alpha 1 plus cos n alpha 2. Okay. So what we have to calculate now? Fundamental amplitude. Okay. So we have to calculate the fundamental amplitude. So you add this and tell me fundamental amplitude. Substitute n is equal to 1, fundamental amplitude 4 into Vs by pi cos of alpha 1 plus cos of alpha 2. So that is the fundamental amplitude. Fundamental amplitude. Okay. So what is the values here? What are the values? Vs is 100, alpha 1 is 20 degrees, Vs is 100, 4 into 100 by pi cos of 20 degrees plus cos of 40 degrees. Okay, just calculate this fundamental amplitude. Tell me how much you will get here. You will get 217.18, 217.18 volts, 217.18 volts. That is what you will get. Okay. Okay students, any other clarifications from your side? Right students? Yeah, question number 10. So with this we have completed all the questions, my dear students. Revise properly, just go through at the last moment. Don't study any new topic or any new concept. Whatever you studied till now, revise many times in a proper sequence, all the formulas and all the diagrams if necessary, some waveforms for power electronics. In the regular course I explain how to remember all these things. So if you go through the last moment QRC and short notes, remember all the formulae. Don't read any new concepts. Whatever you have learned, that is sufficient. Okay. All the best, my dear students. God bless you all. Thank you, my dear students. If you have any doubts, you can ask. Dear students, are you having any other doubts here? Yes. So I hope this GTQ was very much useful for you for practicing the questions. You will understand your weak areas, not only in power electronics, all the subjects. Understand your weak areas and accordingly revise properly. Okay. Don't be panic in the examination. Okay. And maintain your health. Health is also important. Be cool. Okay. All the best. Thank you, students. Good night.